Myself, Mr. A.N.Surde, Assistant Professor, Mechanical Engineering Department, Walchand Institute of Technology, Solapur. Today, we will learn about the basics of simple mechanisms. Learning outcome of this session is at the end of this session, student will be able to determine the number of degrees of freedom by using Kurzbach criteria. Now, in designing a mechanism, it is important to define the number of degrees of freedom, or it is also called as number of movabilities. So, number of degrees of freedom is defined as it is the number of input parameters which must be independently controlled in order to bring the mechanism in practical use, that is called as number of degrees of freedom. Now, in some cases, the number of degrees of freedom that can be determined from the number of links and number of joints. So, we will see a kinematic chain with 4 links connected together forming a 4-bar chain. So, link are connected at A, B, C, D, and link AD is kept fixed. So, here the number of joints are 4, number of links are 4, and number of pairs are 4. So, from the relation between the number of links, pairs, and joints, we can define or we can determine the degrees of freedom required in order to have complete relative motion between the various links. So, a 4-bar chain will have number of degrees of freedom equal to 1, where if we give some input motion to one of the link, that is AB, is rotated through certain angle theta, then the relative position of the link BC and link CD can be determined, and hence a 4-bar chain has single degree of freedom. So, in order to develop a general relationship to determine the degree of freedom, consider a coordinate system OXY. Now, consider link AB as a reference link. So, this is link AB which is kept fixed, and another link CD Now consider any point P on this link CD. Therefore, the position of point P on link CD that can be determined in the following way. So, the position of point P that can be determined by x coordinate, y coordinate, and the angle of inclination of link CD with AB, that is theta. So, any link before connecting to any other link, it will have 3 degrees of freedom. So, when this link CD is connected with link AB having a turning pair or forming a turning pair, then the position of point P on link CD that can be determined by only one variable, that is theta. So from this we can learn that any link has 3 number of degrees of freedom before it is connected to the another link, forming a turning pair. So when a link is connected with a fixed link forming a turning pair, 2 degrees of freedom get vanished and the number of variables required to define the position of link CD or the position of P on link CD is only one, that is angle theta. Now we will consider one example. Number of links are 4. So in this case, in order to form a mechanism, we have to keep one of the link fixed. So there are 4 links, one of the link it is kept fixed. Now number of links 4, they are not connected with each other. So as before the link get connected to the other link, each link will have 3 degrees of freedom. Therefore in this case the number of links, movable links, are 3. So number of movable links that can be L minus 1. So there are 3 links which can be movable. Then number of degrees of freedom, as one of the link is kept fixed, so each link will have 3 degrees of freedom before they are connected to some other link. So it will be 3 into L minus 1. Now consider L is number of links in a mechanism, J number of binary joints. Binary joint means when the 2 links are connected at the same connection, that is called as a binary joint. So the general relation in order to determine the number of degrees of freedom, that will be N is equal to 3 into L minus 1 minus 2J minus H, where N is number of degrees of freedom, L number of links, J number of binary joints, and H stands for higher pair in a mechanism. If number of higher pairs in a mechanism is equal to 0, then the relation is reduced to N is equal to 3 into L minus 1 minus 2J. So by using equation 1 or equation 2, we can determine the number of degrees of freedom. Now as shown in figure A, there are 3 movable links. So from the relation, number of degrees of freedom will be equal to 9. Now when one of the link is connected with the fixed link, the number of degrees of freedom is reduced by 2. So number of degrees of freedom is 7. Once again another link is connected to the second one. In that case again 2 degrees of freedom will be reduced, so N equal to 5. Further, one more link is connected with the fixed link, then number of degrees of freedom is reduced by 2, and that is equal to 3. And when all 4 links are connected together, the degree of freedom will be equal to 1. So a 4-bar chain mechanism which consists of 4 links, it will have number of degrees of freedom equal to 1. So we can understood the relation between L, J and H in order to determine the number of degrees of freedom. This is called as Kurzbach criteria to determine the degrees of freedom. Now we will see one more example where the three links are connected together at A, B, C. Find out the degrees of freedom required by using Kurzbach criteria. So, Kurzbach criteria, to determine the degrees of freedom, n is equal to 3 into L minus 1 minus 2j minus h. So, in this case, number of links L is equal to 3, number of binary joints equal to 3, and higher pair is equal to 0. Therefore, by putting the value, we can calculate the degrees of freedom. So, it will be 3 into 2 minus 6. So, n equal to 0. So, a chain with 3 links whose degrees of freedom equal to 0, that means it is a locked chain having 0 degree of freedom. Similarly, if we consider a chain with 5 links where one of the link is kept fixed, it is connected at A, B, C, D, E. So, number of links are 5, number of joints are 5, higher pairs equal to 0. Therefore, n is equal to 3 into 5 minus 1 minus 2 into 5. Therefore, 3 into 4 minus 10, that is equal to 2. So, a mechanism with 5 links, it will have 2 degrees of freedom, that is 2 input parameters are required to define the position of the various link in a 5-bar chain mechanism. So, by using Kurzbach criteria, we can determine the number of degrees of freedom for a mechanism consist of lower pairs as well as with the higher pairs. The material is referred from the book R.S. Khurmi and S.S. Ratan of Theory of Machines. Thank you.